It seems like we are streaming. So let's go into the Twitch events page and down. Turn the volume a little bit down. Okay, this seems to be redirecting us to the event. We seem to be in the event now. We get some advertisement. Okay, good thing this is muted. Cool. All right, let's make sure everything's in place. Did send the thing on Twitter. I shared it also on LinkedIn. Okay. We got the repo there. We got the apparent version. We will definitely need to talk to Ann Montero in a minute. Okie doke. Cool, we can add README first. README. Boom. And so it begins another stream. I'm gonna get some water. Okay. Service, a static file server. Cool. We'll save that. Yes. Show something here. Oh, okay. I see people are starting to join. Hey, hello everybody. We'll be starting in maybe a minute. Just making sure everything is set up. Let me know if the microphone is either too low or it sounds fuzzy or weird to you, and if the resolution of the screen is not ideal. That second bit might be hard to change on the fly, but the volumes we can definitely play around with a little bit. All right. Today, we're going to be building a static file server. Welcome to this new episode of Reasonable Coding, episode number 10. Thanks for everyone who's following and tagging along on each one of the streams. It's been really nice to have you on board. And if you're new, then you're very, very welcome here. Wait, cancel. Yes. Today we're going to be building a static file server, which httpaf, and this stands for Angstrom Faraday. It does not stand for as fuck, but it is my understanding that it is fast as fuck. So this is what we're going to be using for building this server, and we're going to be exploring how to build it, right? Essentially from scratch. I have not used this library before, so this could be a pleasure or it could be a very annoying experience. I've prepared myself a little though to be able to not spend a lot of time in things that are not related to serving static files over HTTP, but rather things that are related to it. We'll be looking to this library that has been built by Spiros Eliopoulos. We can see his profile here. He works at a company called Inhabited Type, and they're the ones that are building this library. I think this company is his company, and he's the only one working on these things separately. I can't speak for him, but all the software that I've seen and used from him, like Angstrom, for example, or Faraday, has been top quality, top notch. I recommend you take a look at what he's doing and some of the rationale behind why he's doing some of the things. And here's the fellow. Yes. Okay. So if you're ready to get started with me, let me know. and we will. We'll be building everything inside of this small repository that I'm calling Servus. Servus is just Latin for servant, if I'm not mistaken. And I think it's also used in German in the Bavarian region to say that you're welcome. I'm not quite sure about that. Call me out on anything that you think is bullshit. Happy to correct myself on the course of the stream or afterwards. And this is a small repo. It has right now it doesn't have any code other than the small CLI around it, and it's going to be using Dune to build the project natively. The makefile that we have here is just a few targets around Dune that could be avoided. I really like makefile, so you don't have to do this yourself. This is something that I like doing. And let's get started. So the little code I've written, I'm going to walk you through fairly quickly. And if you feel like you're lost, let me know. Ask anything that you want. And by the end of, if you need more information about Command Liner, the framework for building this composable command line tools, I recommend you take a look at the last stream. It's a little bit long, but we went from zero to a fully working command line tool with a bunch of options and automatically generate help page and how the options should be parsed and in a type safe way. And thanks Daniel Boonsley for working on it, for bringing it to life. So our project, I'm going to close this thing, essentially consists. Oops, sorry, that's too much output. On two small modules. One module is called bin, and it's essentially just the binary, the CLI utility that will take care of reading the command line arguments, parsing them into the right values and types, and making sure that we can use them. And then the other module will be the one where we'll be doing the work. You don't necessarily have to do the split. I tend to like to split things into as many small packages as I can, but it's subjective opinion. Just like having a monorepo doesn't mean you have a monolith service, and just like having 1,000 micro repositories doesn't mean that you are not building a monolith. So if we look into main, we'll see that here we define some shared options, and then we define a module called serve, which is a command. And this command essentially has a few arguments, the project root and the port, and it has some documentation there. And this is how we build it and run it with command line. We say, here's all the commands I will support, and then please make sure that we're picking one of those commands, and then exit. Essentially, the serve command, if you look at here, is just this expression that evaluates to this tuple at the end, where the first element of the tuple is a command liner term, which is essentially a function that command liner will execute for us if it has to, that will be applied with some shared flags like verbosity or whether something should be quiet or not, the project root and the port. And it has some information about this term, such as the name, right, serve, the documentation string, which is the one that we set up here, what happens when it exits, what are what are the common options that we need to give it, and then the manual page, which is here. It's just an empty manual page right now. This is a little boilerplate. It's something that I essentially copied over a tool that I'm working on called Cactus to not have to rewrite the whole thing. And I already found a bug. This should be in service. There you go. And the shared options, which are the options that we will have on the side, are the verbosity levels. If we want quiet, then we will not log anything. If you want normal, then we will log whatever comes. Sorry, whatever comes from the application. And if you want verbose settings, then we will ask if it's debug, then we will show the debug level. Otherwise, we'll just show the info. And why do we bother doing all this stuff instead of just taking sys argv and parsing this in a recursion, right, where you pattern match against the names of the arguments and so on. And the reason is that this module here and the one below end up building an interface towards the rest of our application that is type safe. So it's less about, oh, I found a list of strings that may or may not found some of the arguments that I expect, and more about this function, the function served from my module, right, needs some parameters. And if you don't manage to get those parameters, you simply can't call it. Otherwise, you will have a runtime error, which we don't want to have. An upside of having all this information in a typed way is that now the language, the tool, right? And this is me executing the executable, running the executable directly from the path where Dune builds it. Normally, if this was, let's say, yarn, you will do yarn run service, right? But right now, I'm just running the development version of this tool, so I'm just going to use the path. And because we specify no command in here, then the default behavior is to show the help. If we press enter, then voila, we see the help. And the help says, service is the name of the command. You have to give it subcommands. One of those subcommands is serve, and then it has common options like the help or the version. That's good. Which means that if we go into here and we say help, then we will see that serve takes a port. When it's absent, we get a value back. So it will always be an integer value. And it takes a project root. When it's absent is the current root of the wherever you are right now. And it also takes some variables here, like some flags like debug, quiet, and verbose. And I feel we're going to be using debug quite a bit, so I'm going to add very quickly an alias for it, so that we just do dash D, and that works just fine. Cool. So now, if we call serve here and we run this thing, it will say that there's too many arguments. It doesn't know what to do. Oh, sorry, I already had serve. If I call serve, it does nothing. And you might be wondering why. Well, the reason that it does nothing is that in the service module, the serve function that because of the type system is forced to take some flags, some path, and some port, it does nothing. So this function actually is doing nothing right now, which is it's okay. It's a start. We can begin here and we can start fleshing this function out until we get the functionality that we need. Just to make sure that we are actually calling this function, for those of you that are skeptical, we will just run app from the logs module, which means this should always be logged, and we will say whatever formatter we're using, just print hello world. And we're missing a library, so we're going to go into the servus Dune package definition, and here we're going to say libraries, and we're going to say logs. Good. So now we've installed the logs, imported the logs library into this package, this module. If we run this thing, boom, hello world. So we know the code is running, everything's good. Okay, so we have a small CLI that doesn't do much right now, but takes some parameters that we want. We can very quickly verify that if we pass a port and we say hello, then this will say hello is not an integer. But if we pass a port like 1999, then this runs perfectly fine. And if you want to make sure that we are actually getting these values, we can say port. We'll always have a port, right? So we can say running port. And this string that I'm writing here, you may recognize if you've ever done any C from the printf function. It's essentially the same thing. And so we can print in the port there. Now we'll use this variable. And after the bills, we run it, and instead of running on port, we can pass in a port. But if we don't pass a port, it has a default port, and that's good. And then we can just say running on path or serving from path, and then we'll put in the path in there. Path. So we take this out there. Good. But we want to make these things happen inside there. There you go. Does that make sense so far? This will say running from path, but if you say project root source, then it changes the serving from path and it serves from somewhere else. So it's fairly configurable. We get the values that we need in, and we can use them. Now, before we actually get into working with this library and building the server, right? Let's scope out what we want it to do. Let's define exactly the work that we need by defining some arbitrary problem. Let's say the problem is that we have a bunch of files in a folder. They're all static, right? It's nothing being dynamically generated. For example, all of the files inside of these folders, which is the source of the project. And we want to be able to browse it by going into a browser. So going into a web browser. So to do that, sure, we could just write Python simple HTTP server, right? And then bam, we get a server running in there, localhost. And by the way, if you have Python 2.x, this should always work. I think this package comes with Python 2.7. And here we have the directory listing and so on, which means we can serve each one of these files individually. Now, I think that building this directory listing for that lets you navigate through the files, I mean, it's maybe not necessary. What would be okay would be to be able to open these files directly in the browser, which we seem to not be able to do. It just downloads them. But we can definitely go into the folders like bin and so on and see that we have files here. If you see any of these SWP files, don't worry, this is my swap files from Vim. They should not appear in many places. I mostly ignore them globally. And I know that I can disable them. I'm aware of that. Anyways, so we want this command. Oops, if I try to close that, it's very noisy. We want this command to run and serve some of these files to be able to get them. We could define perhaps a smaller scope by saying that after it's running, we should be able to do curl and then do localhost and then the port, right? And then we should be able to get the file essentially by curling here. So we can see if that works with Python. Right, curl http localhost, localhost, and we can do makefile, and we see our makefile down there. Okay, and we see something logged up there. Cool. So I think we could scope this down to what we see on the right. So scope. I'm gonna make a scope document. I'm gonna say when running service and some port and some path and project root path. I should be able to curl any file within that lives under path and get its contents out. So one, I'm sorry about that one thing. All right, so this to me should be the scope. What do you think? Should we scope it up? Should we scope it down? Is there a smaller version of this that we can build to get something up and running and then add features to it? By the way, you should have a chat on the right-hand side of your screen, or if you're on mobile, I have no idea what it looks like, but feel free to use it. Feel free to just ping at me with @ostera. and let me know what you think. Give you a few seconds. No, yes, no. Okay, 1, 2. Hey, how's it going? Pretty good, pretty good. We're just scoping now what we're gonna be building, so that we don't spend 3 hours building something that we don't need. All right, so we'll define these to be the scope. If we run service with a port and a path, then I should be able to curl any file that lives on the path and get its contents out. So essentially what we have right here, which means this will be our test, right? If we can run this thing, or let's say source being Dune, if we can run the same thing here on the right, then we know that we're doing okay. Cool. There will be no generated index automatically. There will be no other magic. There will just be the serving of the files. If we go back into the live stream, I think in the event, that's what I said, but I forget. I am only human after all. Yeah, reads and serve files over HTTP. Perfect. Okay. Cool beans. All right, so now we have the CLI. That means we need to start running, building code to actually serve these things. And this is the part where I know as much as you know right now. I know there's a library called httpaf that we can use. And I know that we need to use it somewhere in here, right? To be able to listen to requests and, stream files into those responses. So yeah, all right. So let's get started. Let's go into the library. This is httpaf. I'll make it a little bigger for people that are streaming on their phones, not to have to squint too much. It's a high-performance, memory-efficient, and scalable web server that's written in OCaml. Great. It implements HTTP 1.1, which should be enough for what we want to do right now, with respect to parsing, serialization, and connection pipelining as a state machine. That's agnostic to the underlying I/O mechanism. And this is interesting because it means that we can replace how we do the I/O without changing how the library behaves. And it's therefore portable across many platforms. It uses Angstrom and Faraday libraries to implement the parsing and serialization layers of the HTTP standard, hence the name, HTTP-AF. Let's begin with the first step. Let's install it. I'm gonna do opam install HTTP-AF, and I think I already have it. And I don't, look at that. Might be in a different switch. All right, so it's installing right now. And while it installs, ooh, look at that. It's a whip, which means we might need to look into examples. All right, that's interesting. I also see that we have 3 different opam files. One of them is the main one for the library. Then it's one that's using the async library under the hood, and another one that's using LWT, which we've seen before in at least 2 different live streams. And we're going to be doing another one soon where we're going to dig really deep into what the hell is going on inside of LWT. By the way, these are the underlying I/O mechanisms that the README was talking about. We can swap them, and the library still behaves the same, but works with whatever you are already using. Which tells me that there's a few of these that we could be using. All right, so let's go into the examples and see what we have in there. And we only have examples with async and with LWT, so I'm assuming that we have to use one or the other. There's no other options. And I will make a lot of assumptions, but I'll make them out loud so that we are assuming the same thing. And if you assume differently, just let me know. Precisely, httpaf. Aha! Thanks, Pontus. Could you do that for me so I don't have to go into Slack? All right, so we have this little package here, LWT example, right? And JBuild files are essentially Dune files. So it includes all of these libraries. The syntax is a little different because it's Dune is a successor of JBuild, and we will need some of these libraries. httpaf, httpaf LWT, then LWT, and of course LWT Unix, because we'll be running on a Unix-like machine. All right, so to me this tells me that after we've installed on this right-hand side, right, we've installed the library, we can just throw it into the dependencies. So we have httpaf, httpaf LWT, LWT, and LWT Unix. I'm going to save, and I expect the compiler to complain about a few things. Interesting. So it actually did not find this library whatsoever at all. So I'm wondering if we have to install it separately. And there isn't one. So my thinking is maybe, right? Maybe we need to use the version of this library that lives on this repository. So we need to do what OPAM calls pinning dependencies. HTTP, okay, so now we can just say, I'm going to copy the link to this address, which should be, if I'm not mistaken, a link to an OPAM file. And I think I can do OPAM pin add like this. Oh, sorry, typo in the name. And it tells me that this package doesn't exist, and I'll say, yeah, create a new package, and then it fails. Great. Master. Not quite. All right, I'm gonna cheat for a second there. I know that in a chat that I had recently with Ann Montero, he actually sent me the exact command that I need to use for pinning. And there you go. You need to pin this thing. Cool. So now I can go out of this thing here. Oh, this is good feedback. Thanks, Chinmaya, for feedback. Should I turn it up? Is it the audio quality that is the problem? Right, so now we can run this command. We're going to be pinning this package to this version, the version that's on the right, which is the exact version that's right now in the repo. So if we do yes, then it's going to ask me who I am, and my name is Ostera, and my password, don't look. There we go. What? But that is my password. And it says that it could not synchronize this thing. And I wonder if this is a problem with the fact that we have already installed HTTPF before. Or maybe it's just that we need to add .kit at the end. So this is gonna ask me 2 times every time? No. Why? Huh. All right, let's quickly go into opam docs and say opam ping. Someone on the internet must have seen this before. Okay, let's start here. I'm going to go into the conversation. This is old. This is new. This is from May. This is not too old. Okay. I mean, the JavaScript world, it would be eons away. Pam pin. Nope. Let's see what else is here. Switch to Dune by Al Montero, the god. Huh. Issues. Maintaining it. Dismiss. Let's go into this commit and see what. Yeah, but this is exactly the Git repo that I wanted to pin it to. Why would it not work in that way? So I will do the T and then there and I'm. Oh, right. I was using the Eliopoulos. I was using Eliopoulos instead of inhabited type, so maybe that's why it didn't work. Sorry about that. Happens sometimes. Cool. It's installing now. Should not take long. Oh, thanks, Pontus. Thanks for posting it on Slack. And we're good. It has finished. I'm quietly going into the Slack and checking to see for that channel. 1 sec. I'm checking on my phone. Nice. Awesome. Thanks. Okay. So now that we have that, we can try to just save the file again, and then it will try to build the thing again. And it built successfully, which means we probably have all the dependencies that we need. Great. So after we have the dependencies, that means our tool will continue to run. It still does nothing, right? But at least we have all the dependencies we need to start building the web server. So let's go back into the example, which I think was in here. Nope, but still this is the same repo. So I'm going to use this window for example, LWT, and then we saw that we have 3 different modules. We have a get, a post, and an echo server. I would say the echo server is the smallest thing we can build right now that does the full loop, getting a request, doing something with it, and giving a response back. So we can start there, and if it works nicely, whoa, this is a bunch of stuff. Okay, and if it works nicely, then we can continue to add it. So from what I see here, I'm going to start bottom up. Okay, so we try to build up a listening address with the loopback and the port. And this is the essentially an address that we're going to be using inside of the server somewhere to listen to I don't know if I should call this that a socket that we bind to. I don't entirely know what this ends up being. So I'm gonna go into the OCaml docs, into OCaml docs Unix. Here we go. And somewhere in here we should find that the same, what is there? The same variant name. Oh, okay. So this is a socket. Good. My Unix knowledge is not the best, so I'm learning as I go. The type of socket address Unix name is a socket address in the Unix domain. So this is a Unix socket. Name is a file in the file system, and inet under port is a socket address in the internet domain. Okay, so we're building a socket, right? First thing here is we do build an address, a socket, and then we create a promise that will have the result of this function as its value. And the result of this function, no, wait, that's wrong. Forever. We just spawn a piece of work that will run concurrently. And this thing establishes a server with client connection using this address and a connection handler, which I believe is the function that we defined at the beginning of the file. Okay. And when it receives a server, it knows that we have connected to that server. Okay. So this is just starting the machinery for the server. Like this, and this thing here is the thing that does the actual work for starting the server. This thing here is just printing that, hey, we're good now. The server is up and running. And this little bit down here is the thing that will make the command just continue to run forever. Now, this server over here is the one that will take care of essentially receiving input, reading from this listening address every time there's a new request, and executing the connection handler. Now, I'm not entirely sure how this happens under the hood, but so far we can do, we know that this will do the initial setup of the server. This will keep it working forever until we exit it, and this will bind it to an address. So there's a few things that we know that we will need here that we can start moving over right now, which is we want this application to start and just keep waiting. So if you run serve, it just continues to serve things until you manually close it. And we can do that fairly easily. So the first thing we need to do is we need to call LWT wait, which is not it's not a blocking call. It's just a function that returns two promises. Actually, it returns a promise and it turns a promise resolver. And in here, we essentially want to use a tuple deconstruction, pattern matching, to be able to say, okay, the thing on the left is the promise, the thing on the right is the resolver. We never want to resolve, so we can do an underscore to ignore it. And on the left side, we can say forever, which is a promise that will never resolve. And then we can just call LWT main with run, and we can execute that with forever. So if we save this thing and we run it again, we should see this output being logged and the command not finishing. And that satisfies our hypothesis. So this is essentially running and continuing to run. It's not executing any resources right now, but it is continuing to run there. Okay, so we can Control C and signal it and finish. Then we can go back to the code and say that we probably want to do something like this. So right now we are showing that we're running on a port and serving from a path, but we should probably do that after the server has begun. And we know that we need to try to build an address. Building this address, however, is essentially putting together a data structure. With the port. All right, this is a reference, so they're taking the value out. And this thing here must be defined inside of Unix. We can take a look at that. We can say unix.inet address loopback. Okay, so that would be 000. Cool. Okay, so we can put together this address by saying address inet. Is it interesting? Inet, and you see that it takes a tuple where the first one is an internet address and the second one is a number, which should be a port. So for the first element, we can put in, I'm going to do a local open there. For the first element, we can do inet any loopback, and the second one can be the port. And this will be our address, listening address. Cool. So far, so good. Sorry. We don't need them. There you go. Extra parentheses. I never know when it's too many or too few with reason. And immediately after this, we know that we need to use this address, which right now is being unused, and that's why the compiler is complaining. We need to use it, so we need to use it in a call to LWT-IO, establish server with client socket. Why? Because we want to be able to listen on a Unix socket, then we need to use, okay, that part makes sense. I mean, I understand exactly why we need to do it. We have a Unix socket that we're listening on, and then we need to route or listen to the traffic going through it to be able to use it within the application. But it's not entirely obvious that we need to use this particular function to do this. Well, because I would expect some higher level abstraction. But that's sort of, I guess, what we were talking with Anne Montero today as well. That it's kind of beautiful or horrifying that you can go all the way down to file descriptors and all the way up to monadic operations in the same language in the same place. And as you start digging on any abstraction, and very quickly you reach the bottom of it. There's not much more to work with. It's a very shallow platform, which makes it a little confusing at first, perhaps if you're used to having a lot of abstractions, but it also makes it easier to understand, because there are less things to understand. Okay, so let's take a look at this thing here, and I'm going to be opening the LWT documentation here to make sense of that function. And this is established. Good. And this function call here, I'm going to switch to recent syntax so it's more coherent to what we already have. Cool. Creates a server which listens for incoming connections on listen address, which is, where is listen address? Here, the socket. When a client makes a new connection, it is passed to F. More precisely, the server calls F client socket client address, where client address is the address, the peer name of the new client, and client socket is the socket connected to the client. Great. So every time someone connects to the listening address of our server, then there will be a new socket created for that connection, and then our function that will handle these connections will essentially receive this socket, which means that's where we will be writing stuff back, I believe. The server does not block waiting for F to complete. It concurrently tries to accept more client connections while F is handling the client. When the promise returned by F completes, that is, F is done handling the client, establish server with client socket automatically closes client socket. Great. So after our function for handling this request is done, then this This function will take care of closing the client socket for us. This is a default behavior. It's useful for simple cases. And for robust applications, you should explicitly close the channels yourself. I think that for the time being, we can try to use this as it is. And if we find that it's a problem, then we go into more, we will explore alternatives. All right. So why was that block of code? What was this function called, right? The client address. Why was this block of code, which I'm going to expand my editor so we see the full signature. Oh my God, we can't see the full signature. Damn. Why was it wrapped inside the async call? We'll see why in a second. And then here we have to pass in the listening address. And then the next thing, this will be our connection handler. Some function that will handle the connections, right? And now if we call it again, this is a promise. And the reality is that this will not actually do any of the work. This is just a value. It's a promise, right? That will be fulfilled at some point in the future when we finally establish a connection with the server. So if we call it here right now, then it will return immediately, and then our application will be left hanging, and I believe nothing else should happen. So we can call this again, and we will need to define a connection handler function, so we can do that here, connection handler. And this function, I have no idea what signature it needs, so if we save, then the compiler will complain and let us know. It says it's a function that will take first a socket address, and second an input and output channels, and it should return a promise. So this will be the client socket, and then we will get a tuple here of the input, in channel, and out channel, and then we need to return a promise. A quick one that we can return right now is just return unit. And we probably need to underscore these things here. All right, so if we go into line 11, you'll see that this thing here, right, returns a promise of an LWT IO server. We can't just call this thing, we need to actually consume this value or ignore it. If we ignore it, then I don't expect this thing to work. If I run it, okay, I don't see anything working. I'm completely unsure if this value will actually be part of this loop, of this execution. I want to think it won't. So let's instead follow the example and see exactly what's going on. So we know that we need to wrap this in an async, and we know that we need to sequence this so that after we have successfully established the server, we print something. Actually, we might try this thing first, right? So we ignore the returning value, but we know that immediately afterwards we will get a server that we ignore. But in this server is where we're going to be trying to log in stuff saying, hey, I am running. This thing is good, right? And to get access to this magic operator, which is the monadic bind, also called flat map in other languages, for promises in this case, we need to do an open. We're going to open the LWT infix module that defines a lot of these operators. We see the signature you'll see below is essentially just a bunch of operators that have weird symbols for doing very well-defined things. Okay, so if we save, we need to return a promise here as well. And because we are logging in the context of a promise, we should probably use the promised version of the logging so that we can essentially say, oh, log this thing first, and only if you've logged this thing, then log the second one, and so on and so forth. And we can do that in this way. There you go. Cool. Now we're getting a linker error. We don't know about this module, so we go into here and we say, oh, we have the logs module, but we did not add the logs.lwte. So if we add that there, then boom, everything builds and runs. And what should we expect to see? I think that this will actually not log anything. My theory is that this value on the left, right, LWT established server with client address, doesn't actually get executed at all. This is a promise that doesn't get resolved because we're running outside of the main event loop. But we'll see what happens. Okay. Did this compile? Yes. Did I save this? I am so confused right now. Let's see the chat. It's refreshing. Oh, hey, I'm Montero. I did not see your messages here. It's an address, not yet the socket. It's going to be localhost. If you want to bind to 0000, you need internet address any. Cool. All right, so it's a good thing that we used. Oh, I used any. Is that the one that is changed here on the left? Loopback. Oh, interesting. Okay. We continue to use any then. Thank you for that. I did not see the comment. Great minds think alike, they say. I think in my case, it was just a mistake on my part. Yeah, I'm so late to the party. I'm sorry. I should be first to the party. All right. So this promise, for some reason, does get executed. And maybe you can help us understand a little bit why we actually see this output. Why is this sequencing happening? In other words, do we actually need to do the async here? This one. Guess what? Right, perfect. That part I understand, right? When we create a server, now it's created somewhere, it's listening. There are sockets under the hood that are already doing the work. Exactly. That's the bit I was curious about. So if we don't need it, I'm just gonna ignore, and then we'll continue. And if we find that we need it at some point, then we'll add it back. Okay. So before this gets any messier, I wanna um, I want to do a small module here called HTTP. And this is the server that we want to start, right? So we can just say start, and we'll give it a port, and it will do this thing for us, and it will just return a promise for us. Do I want to do, maybe I don't want to do that. No, you know what? Let's just wait for a second there and see where it takes us. Let's go back to our connection handler. So our connection handler just returns this unit, which is a promise that resolves to nothing. That I think it's already resolved to nothing immediately. Right. As Montero says, running a sync here will run this function, right? The starting of the server in a different thread, and then it will just continue waiting. But in this particular case, I don't see the point of just starting the server in a different thread if starting the server is non-blocking. I mean, it will block while it starts, but immediately afterwards, the server just continues to run. If we were doing more work immediately afterwards that needed to execute as fast as possible, then maybe it will make sense for us to async it. If you think differently, just let me know, and I will try to check the chat more often to make sure that I'm not missing good comments. All right, so if we go back into the connection handler, we'll see that there's quite a few things that we have here. We have a connection handler, a request handler, we have an error handler, and then we have httpaf create connection handler that receives each one of these. Okay, so that means to me that we need to probably just handle this thing separately. We can just say connection handler will be the httpaf, and then LODT, and then server, and then create connection handler. Is that the one that we were using? Yes. Which takes no config whatsoever. And it will take a request handler by name, and it will take an error handler by name. Now I wonder if we actually need to create one of these every time we get a new. Yes, okay, so because we will need to use the socket. Will we though? No. Okay, so I was thinking that maybe the connection handler was a function, but it isn't. This is just the type signature that will give access to the request handler and the error handler to the in channel and then out channel via lexical scoping. But it appears that essentially request handler will get everything it needs, and so will the error handler. So we can begin by splitting some of these things out. I don't particularly like doing this. Maybe we can just do a local open internally to another module so that we don't clutter the scope. But let's begin at the beginning. We will need to define a request handler somewhere, right? And we can use this one as an example of how to define one. So let's say there will be a request handler. And a request handler, if I just do this, then the compiler will complain and let me know that the type is wrong. And I know that I will get here a socket and a request. I actually seem to just get a socket. Okay. Request handler takes a socket and a requestee and returns unit. And here, yeah, this seems to take less parameters. Maybe because it's evaluating the names. No, it seems to not be evaluating the names there. Okay. All right. So this will take a socket, which I assume is the client, and it should return a server request handler. Now I get it. And the request handler, what's the type of a request handler? So httpaf, LLT, server, request handler. This thing is a server connection. Almost there. Okay, httpaf dot server connection, and then what's the name of the type here? It's a request handler. And this is parameterized by what? By a Unix file descriptor. Unix file descriptor. So what's the type of this thing? Okay, doesn't really tell me. Okay, so this is just an alias for a function that takes a rec_d type with a handle of some sort and returns a unit. So I'm going to assume that we get a client here and we also get a request. And this looks a lot more sensible if you come from a much higher level framework for building HTTP services or servers. You get a client with some data with the client, and you get a request. And you need to return a unit. So let's do that. Let's return a unit. And now we need to define an error handler. So we can just start by saying error handler. And this thing takes a client and returns the server connection error handler. So we'll see what that is. And that seems to be another variable. Line 10. Yeah. It takes three things. It takes the request. Okay, it takes a socket first. If you look at this line, it takes the socket first and returns an error handler. But an error handler is an alias for a function that takes three parameters and returns a unit. So it takes the client, and then it takes a request, and then it takes an error, and then it takes what I believe is a function from headers to the body. So headers, let's say some fn, and then returns a unit. What are we missing here? Okay, let's see how it's done down here. Oh, right. This is the name parameter, and this is to start the response. Okay, so client, and then we get the request. That it's an optional parameter we can ignore, I guess. And they might not be a request object, and then we get an error on the response. So I think that if we do request, am I missing anything here? Error, start response. There's 4 of them. There's one that's named. Everything else is unnamed. Socket. And it should return a unit. Checking the chat. Nope. It's updating. Nope. All right. So the error handler function seems a little bit more complex than I expected. But let's go back and see the type that we expect here. A request BCD. And that's all right. And what do we have here? We have A request BCD. This expression has type socket address and then request of A, B, C. But isn't that exactly what we have? Let me try to copy the type and tell it this is what I'm returning. Of course, I need a fat arrow there. Okay, so line 6 now. This will be that. This request is now connection handler. Okay, and the rest is a connection handler. Cool. So that kind of makes sense. Oh. Okay, so I was missing making the argument not just named but also optional, which is this is the way you would do it in Reason. So now we're going to line 21, where we seem to be having another type error, and it's telling us that this expression, right, takes a config, socket address, and a file descriptor, and returns a promise. Interesting. But an expression was expected of type, the first is okay, the first is a socket address, and then instead of one file descriptor, this should be a tuple of two file descriptors, input and output channel. So let's see what they did here. Somewhere in here, the connection handler, right, specifies that we're going to be using a single one of these. Huh. I wonder if the example is out of date. I don't think so. I think I'm just messing something up, but it's possible. So this expression, this function over here, our connection handler, right, takes a socket address and takes one file descriptor, and then it's done. Never mind, I thought that I was missing the none here, which is there as none. I don't quite get this. There is a socket address, there's a file descriptor, and returns a promise. But this thing here has a different signature, which makes me wonder, where is the input? Where is the parameter to connection handler? Config, request handler, is there? Okay, so this is correct. It takes a socket address and a single file descriptor afterwards. And this function here, okay, so now this function is the one that takes something slightly different. Are we using the same function, establish server client socket? No, we're using with client address. Okay, so establish server client socket, and you say that thing here. Yes, precisely. No type errors, but we get a lot of errors about variables that we're not using. So if we ignore all of them, then, I mean, except for the request, which I don't think we can ignore. Yeah, this fails. All right, so that means, however ugly this handling that we're doing is, it's type checking. We're passing in the right information to different places. That kill all there was not a subliminal message to TypeScript. This is something I have to do in the past while benchmarking the compiler with a really big application, 8,000 modules. BSB, by the way, did really good. It was like 17 minutes. But I digress. Anyways, we have built this server. It listens to things. It does nothing with the requests. So let's have a look at how each one of the requests actually works. We can have a look at the request handler and separately the error handler. I think right now the request there, yeah, let's just begin with one of them and then we'll see where we get. So the first thing that we seem to do is get the request out of the descriptor. And then we will switch on the match on the method. Great. Cool, so let's do that. So when we get a request, this will really be a request descriptor. And then we will get the request out of it by using, and I think it will be safe to say we can do a local open of httpaf here. And we will say request, I think D was the name of the module. Let me just say that first. Request will be httpaf. Let me just take a look at the name of the modules. Rec-D, and then I forget. request. Right, this gets a request type parameterized by something and gives you a request out. So if we give this thing a request descriptor, then we get a request out, which is great. So essentially, this takes care of figuring out how to turn whatever I/O mechanism you're using into an object, a value that makes sense in the context of the domain of httpaf. And in here, we can just do request method. I think we'll be able to complete that for us, and it's not. That's sort of sad. And we here wanna do a get. We saw that we do a polymorphic variant to get each one of the methods out. And I guess, okay, so we can just continue using the request descriptor to get stuff out of it, to be able to use it. Again, a little lower level than we're used to normally, but it should do fine. Now, for a get, we should not take care about the body, but we should probably look into the path, the full path of the thing. I guess that if you're building some sort of like web framework around HTTPF, this is where you would inject a router. Cool. Okay, let's just get then. Let's see what all the things we have in recd. We have the body, and we have the whole of the request. So what is really this request object? Aha, we don't know what it is. So let me just remove this thing here and just say that we will return a unit after ignoring it. This is a request T. And as a request T, it has headers, version, it has a target, and it has a method. Yeah, and the rest is all the modules that we have in the scope right now, which is plenty. More than I'm happy to have. Okay, so let's take a look at what those do. Hopefully the library will have docs around that module. So if we just go into the code, oops, I guess lib somewhere, recd, request. Here we will have target, and there is no docs about it. But if we go to the MLI for, and there is no file for that, there's no MLI. There's an HTTPAF MLI. Does this include everything? It looks like so. Okay. So here's the recd module, and we should look for the request module. Say okay. So I don't know what target is. Might not be what we are looking for. I figured that headers here might also be something we're looking for. I am not an HTTP expert, and it's funny to do these live streams and dig into domains that are familiar with new tools, because you realize that there's a lot of things that you do know, but there's so much more that you don't. Things that you assume because they're always there being done for you by some framework. It's a humbling experience, if I'm allowed to say it in that way. Okay, so let's take a look at the method of the headers module. I don't think this is to invalidation of the headers. Nope, it doesn't seem to do so. I'm going to go back to the example and have a look at whether they are getting the path from anywhere. Right, I don't see it in this echo server. It might be that it's just forwarding whatever you pass it back into you as a response. So I'm gonna save this file and I'm gonna open a different one. I'm gonna open the get example. And we're gonna go from the beginning. This does things in a different way. And I think this is actually making a request rather than setting a handler. So it tries to get the addresses. And if you do get something, you will connect to one of those sockets, and after you connect, you create a request. Yeah, this is not a server. Yeah, this is making a request. What about post? Response handler, kind of the same thing. Okay, but now we can take a look at the create function, which clearly has two parameters there, post and then this string that I don't know what it is, but we can have a look at it. So it should be inside a request.create. So if we go into the big file, the MLI, it has all of the docs for this module. Then we can do request, seg, and this is the. I'm gonna say this is the target. I'm gonna say I don't see any other strings around here that are being stored anywhere. And the version is here, the headers are here, right? The method you're passing in is also math here, and the string has to be the target. Okay, so essentially, if we get the target out of this request, then we'll know more about the URL that you're hitting. So I'm gonna propose that as a first step, we just log that out. Whenever you curl it, then it just says, hey, and it prints out that you're hitting that URL. So whatever it is that you do, we're gonna be doing logs, LWT, app. Let's actually do, let's do app, and let's say get. No, we can't really say get right now. Let's just put the path in there, target. And that will be our promise, the promise that we return. And I wonder, yeah, this should be the same thing. Line 13. Oh, okay. So we're not using the client here. And this says, huh, okay. So this is expected to return a unit. Is that what we expected to return from before? I can't quite remember. Yeah, it is, okay. So I guess that we just need to return something immediately afterwards. So I'm just going to use logs in here so that it logs immediately. Cool, we have a bunch of unused variables, but we can just ignore. Yes, I made an error. Thank you, compiler. And now on line 16, we get an error because this is not expected to return a unit. If we go back here, we'll see that this is expected to return a unit. And what the hell? Of course, we can't do this. These are different types. What am I thinking? Ignore. Bear with me while I get used to these things. Good. I know we have this unopened, unnecessary open. And if we run the thing again, then we expect it to print some paths, and that's pretty cool because it if I do hello world, we do see printed the path. We have a web server, HTTP server at least, that will give us the path that we're passing in as a string that we can use, right? So now we just need to match on the method, and if the method is get, then we get the path, and we just need to return this. So let's investigate how to return the path back to the person. There is something called a response module, and response content type. For the time being, we could ignore the content type, and we could just return, build a response back. So if we the response, then we have the response module, and in here we have create, which has so many parameters. But we have a status for the response, we have the headers that are optional, we have the version that's optional, and the reason. So the status that we want to use for this thing is probably in status, yeah, and it has to be okay, maybe. I wonder if it's a variant somewhere. No, it doesn't seem to be. Okay, let's just do of code, and let's do 200, right? Now we have a response. Oh, we can do, okay, that's much nicer. Okay, uppercase, all of it uppercase. Respond with streaming. So this will stream the response. No, wait 1 second. This just creates or what is this response body? Respond with streaming. Let's take a look at the type of that. Rect respond. Oops, sorry. httpaf rect.respond with streaming. You know what, on Montero, I think I need to activate notifications for the chat here. I am not getting any, so I see your messages much later than I expect to receive them. I mean, yeah, I receive them on time, but I just need a ping that says, hey, someone's saying something. Yes, if you can do that, that would be amazing. That's a great idea. Okay, so we're building this response object now, right? That we want to use to return the value back, and we have the value. The value is just target, request target. So it seems that this recursion over here is essentially going to stream the file as fast as it can without buffering it. I'm not entirely sure how this works right now, but it looks like it will write chunks into the response stream until it's completed, and once it is completed, it will just close the response body, which makes me think that if we go into the module, there will be a response like this one, respond with string. And this will take a a response, and a string. So request, response, and a string. Okay, so if we compile this thing, there is something here that is not the type that we expected. This is a request T. Oops, client. No, I'm sorry. Request T is the request DD. So if I do request descriptor, then this should build, and then we can kill the server, and we can execute it again, and we can call it, and what we expect now is to log the path, but also see it on the second terminal, and it should log it and immediately close. I mean, should log it and immediately return. Curve should return immediately. But that didn't happen. Okay. Interesting. Why? I wonder if the head connection close is necessary for this to work. Whoa, 14 messages. I'm here now. The fade command I gave you should work. When you get set up. Yeah. It was just the name of the user. Yeah, absolutely. One question about this. One question about streaming. Is this streaming? I don't know how bad the delay is. All right. So is this streaming the file to the client or the contents, the data really? Good. Cool. We can talk more about how that works when we start serving the files. Okay. So in the meantime, um, when we run this thing and make the requests, this is not ending, and it's certainly not finishing. So I'm gonna make just it might be that we are not passing the connection close header. Interesting, but it's not doing that. I don't understand why. I would expect it to do that. Respond with string. Oh, I'm also just gonna open HTTPA here. Yeah, I need to tell it exactly how much to expect. Yeah, you're correct. If I don't say content length, then it doesn't know how much to read back to be able to close on the client side. All right, so let's do this. We're gonna give it a header, and this will be header. Let's just run this thing here. Let's do headers, and we'll do headers. It's a module that has a function called of list, from what I read before. Of list, from list. What? Right, headers. This is exactly what I was trying to autocomplete. What the hell? All right, and in here, and we need to give it what? Just strings. Okay. So content length, and we know the content length is going to be the target's length. But of course, this is supposed to be tuples. And we need to turn this into a string. So string of it. Okay. So now if we actually do curl with what is it? That's I, see headers. Let me just revert this change real quick. I wanna. What? Huh. Interesting. Anyways, if I have the change there, which means we're gonna be sending back this content length header, then I should expect to get it here. And yet, for some reason, I am not seeing the response. Okay, so why is it that I'm gonna do my curl here? Give me a second. I want to see the headers, but I don't want to see only the head. Okay, so thank you. I went into cool. All right, that looks much more like it. Great. So we have a very small HTTP server, and by the way, I would definitely take you up on that easy HTTPAF library that we could build. I think keeping things high level, but also letting you, still show up the I/O mechanisms will be very nice. Um, Now we have a web server that whatever path you throw at it, it will just return it to you. It's a small echo server, but it's showing some important things that we need to sort of remember. I'm gonna write them down here in scope, and is the one we need some promise that never finishes to keep the server running, and two, we need to we need to talk at a very low level to get the basics up and running. Essentially, we need a Unix internet socket, right? Yeah, and that should be enough of an example of some of the low-level things that we need to do. And after that, we define our request handler and our error handler, which I reckon could be defined with some very sensible defaults. And as I mentioned before, this will be the ideal place to hook into any routing framework that you have. Essentially, you could take request.target and try to run a bunch of pattern matching, regular expressions, or whatever logic you have to figure out what functions to call somewhere. It would be nice to toy around with a framework that does this in a very type safe way. And I'm thinking that something like command liner is pretty much the same thing. You get a string of arguments in, and you need to make sure that not only they are in certain order, but also that they're parsable into certain values. So if you have a path that goes like hello, and then this is supposed to be a string, right, um, for a name, so that it goes hello John. And then if you go hello 1 2 3 4, then this fails nicely, saying wait, I expected a string, and so on. So it protects your server from a lot of crap inputs. Anyways, we essentially want to take this thing and be able to return the makefile's contents. Right now we are returning the path to it, right? And that's fine. But we want to take this up a notch. I think that if we were to write the things that we wanted to accomplish today, was one, start a server, an HTTP server. And then the second one was, I'm going to just write notes here below so we don't mix things. Goals. Start a server, and then second one was respond to clients. And now we want to actually find the files, or return the file contents to the client. Cool. And because we have the path, right, to the target, we can look for that file that is located in this particular path, starting at the current directory. So that's sort of an assumption that we can make, is that if you request any path that begins with slash something, then it should be a folder in the current directory. And yeah, I understand that someone could go to like localhost and then do dot 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 and access some other path somewhere. But these security considerations are out of the scope of what we're doing right now. Definitely something to keep an eye on, but not something that we need to do right now. Okay, so we don't need to log the path anymore. Maybe we can say requesting file. We need to check if we found the file, and to do this, oh, this will be like the 7th time that I make an exists function. Antonio, do you think we can just use boss here? Will it be a problem given that we're running with it within LWT? It's essentially a blocking Last resort. Is that better? Does that work? This just keeps happening. I think there's something wrong with the way I'm pairing the device. Anyway, if you can hear me, then that's all that matters, and we can move on. Cool. So we are back. So essentially, we want to read the file if it exists, and if it doesn't exist, we don't really care. We just say there isn't such a file. We could go as granular as saying, no, you don't have permissions to read the file or not, which we could do if we had fstat to bubble up some of these errors more granularly. But right now, we just want to know if there is a file, what are the contents, and if for some reason you can read it, then we couldn't find the file. And we can encapsulate this thing in a function. Let's call it read file, and this will take a path. And the path will be very, very close to the target. It will actually be the base path that we have, which is, we can assume is the current folder at all points, right? And then the target. This means that if you're requesting makefile, right, then this will be /makefile instead of just makefile. And this function is not defined anywhere, so we're gonna actually just make a very small file module here to not pollute the global scope with another function that looks like something else. We have readline and readlines and so on. So here we have read, and this will take a path, and in here we will essentially just we'll do file exists, check, right? And if this path exists, and this returns a boolean, right? So switch. If it exists, then for the true branch, then we'll try to read this thing, and for the other branch, we'll just say none. If it doesn't exist, we return none. But if it does exist, then in here we can just try to read it. And read there. I'm actually going to take a look at how you read reading the file, which I think you're not quite. You're just responding with file, and this is something you define in your utilities there. So I'm gonna copy the file reading from. I'm not gonna copy the file reading from anywhere. I'm just gonna use the library that does this for us. Spiros Eliopoulos. There's this library called BOS, which is made by the same person that built logs. Line 8. Hold on a second. One sec. Right, okay. The same person that built logs and command liner. And this is not where I want to go. I want to go in here. I want to go into boss. There you go. And BOS is, I think, basic operating system. And it has a lot of utility functions to work with paths and files and directories and commands and lower level Unix access. Daniel Boonsley does pretty good work. Okay, so both file has a read function that will read the whole of the contents of a file path as a string in a result. And this result is just a type alias for the OCaml result type, so we can use it as well. So what we want to do is we want to say if you give me a file path, then I'll try to read it. But if I fail, I will just return you nothing. So if we do boss, which is the module, the package that we opened, and we open the OS package, which is the module that wraps the file package, and I know, yeah, it's like so many levels. Here we have a function called read that will take a file path, right? And it will return either a good thing or a bad thing, either the contents or an error. And because we know that the path that we have is a string, then we can turn this into a path that both knows how to deal with by calling fpath.v. So we can do path and then fpath.v, and then this just gives us a type for dealing with paths in a more principled manner. Because when we say a path is a string, it could be the complete works of Shakespeare and it will be a valid string. Which I reckon it might also be a valid path, depends how they are encoded. But we want to take a look at this thing, and whatever this returns turns into, we want to use for coming up with the resulting value. So when we get an OK here, then we have some contents, and then we will just say, okay, here's some contents for you. But if you get anything else, then we just say, oops, no, go away. And if you look at the signature of this function at the bottom left of my screen, you'll see that it takes a string and it returns an optional string. So this will read the file for us if it found it. If it doesn't, then it won't. So now we can essentially just switch on this file, and if we find some file, right, then we'll have the contents in here, and then we can respond with the exact same thing that we had. And else, if we found nothing, then we can just respond with something slightly different. We'll make another response object, but this one will be not found, and it will have no headers whatsoever, and the response body will be an empty string because there is nothing to be said. So we can tell by the formatting that there's not too much wrong with this code, and I think the problem will be that the variant doesn't exist. Is it not found like this? Cool. All right. So now the next thing is that the contents are not being used to respond to send them back to the client. We were still using the request target here, right? So what we need to do is just take the contents, right, and calculate the size of that, which will be the length of the string as an integer, and then we need to respond with that instead of the request target. So if we save that thing over there, and then we can also just say like content len to make this a little flatter. There you go. Now we should be able to run the server again, and when we request makefile, then this will be appended the current directory, which is where you're requesting the file from, and we will attempt to read it by checking if it exists, and if it does exist, by trying to read the contents of it as a single blob as a single string. If we fail for some reason at doing any of that, then we'll just say none, there's nothing there. And then if we did find some contents, then we will calculate the length and say, okay, whatever response you give, it should have this length. And then we will create a response saying, okay, with these headers, and then we will just tell the framework to write into the socket this HTTP response that would include the headers, the status OK, and the contents. If we did not find a file, then that means our job is much easier. We just need to say, let's create a response with status code not found, and let the framework write that to the socket by saying the status code is not found, there are no headers, and the body of the response is empty. So what I expect to see here on the right hand side is the contents of the makefile after I press enter. So let's see if that happens. I'm going to clean the console first, right? And enter, and boom, we see that. We see in the logs above that we are requesting this file, which is great. And in the logs below, we see all of the headers, right? And then we see the body of the file, which means if we call this without the verbosity flags, the V stands for verbose, we should just see the file. Cool. We just see the file. All right. Great. Amazing, everybody. Round of applause. Good job. We've actually managed to get a very small static file server using httpaf, and it is doing the thing that we want it to do. We have tons of ways of doing this. We can definitely make improvements so that you can't fetch files that are in other places or escape the current directory, or we could generate an index file by reading first all of the current directory and making sure that we don't miss anything, and then you have this small index file that lets you click around in the browser. But so far, if we go into the browser on this address, we should either get a download for this file or see it on the browser. So I'm going to do that. I'm going to go in here. I'm going to open this. If I say make file, and we get it here. Great. Let's try with something else. Let's go to source bin main re. Boom. It works as well. Let's try with one of the internal files that are inside of the Dune folder. Maybe not the executable one, but perhaps we see the ML version of this same file is inside of build default source bin main re. So build default source bin main reml. That one actually we got for downloading purpose. We got downloaded. I do not know why. I'm gonna close this. There you go. But yeah, interesting. I wonder how much faster this is from the Python version. And I'm gonna go to Antoine, which I'm pretty sure he's. Yeah, I'm not saying the content type. Is that why it's been downloaded? I think the browser will just try to infer that from the. No, it has no idea that you're downloading anything. So maybe we can just use text plain. There is a header, and the headers are ways that we tell the browser and the client that there are metadata about the contents that we are returning. There's a header that says this file or the contents that you're about to receive that have this length, right, are of this this type, and these are MIME types, if I'm not mistaken. So if we do this again and we close the server, so we should a camel magic mine. Yay, that's nice. Let's have a look at this one. Maybe we can use this module instead of hard coding everything to, yeah, okay, let's begin by installing this module, which I guess we can do with install camel or pam install magic mine. Because right now we're gonna say everything should be text plain, and text plain is just plain text, which means some of the things that we download default. No, this is still downloading this file. I don't understand that. I was expecting it to just display it here. If I go to the network tab, I'm gonna make this bigger. I'm gonna put it inside. Then the request that we send should have some headers that we can take a look at, right? Headers. The response says text plain. Okay. So if we use this URL instead, what do we get? Oh, this is a binary file. Alright, that explains that. The reason this file is being downloaded is that it's not actually a text file, it's a binary file.
Cool. All right, I'm happier with that. Let's install Magic Mime. And if, oh, maybe Magic Dash Mime? And it reminds me to Magic Mike, at least me. Not that I have seen the movie, it's just hilarious to think that it might be the case. Cool. So now we can include this here, Magic Mime, I guess. And if this builds, then we should have access to that module, Mime. Nope, we don't. Is it? Oh yeah, it's a dash. Keep doing this. Magic Mime, and then we have a lookup there, which means if we just do a lookup of the target, then we should get this automatically fixed for different file types. Cool. Let's see what that looks like. We don't need to do that. We can do makefile first. Of course, I need to run the server first. Otherwise, we'll never get anything out of it. Cool. The content type is an application octet stream. If I, let me just, I'm gonna just do touch, hello.css. And if I try to serve that file, the content type is text CSS, which is great. Not only now our server serves the things that we ask you to, but it also tells us exactly the type that the thing is, so that the client, the web browser, can do their magic with it. This is nice. I thought it was going to take a lot longer, and yeah, it's super low level, right? But it's doing the thing it has to. If we were to make this a little higher level, then maybe what we want to do is passing the request object. I mean, I would like to have a function, like let's say we have a module called like endpoints, right? And in here, I would like to have like a serve file endpoint that just takes a request and a response object. This will be very familiar to anyone working with, let's say, Express.js or Sinatra or any other web server out there. And honestly, it will be pretty much the same thing. I think it will make no difference at this point. Maybe if the business logic was much more complex, it will make sense to start splitting some of these things out. I don't know. What do you think? Ha ha ha, call it, yeah. Nice. So something I'm thinking is that maybe we want to benchmark these things. So I'm gonna change the logging levels. Actually, no, I'm gonna leave the logging levels there because Python simple HTTP server, oops, sorry, will still log things for us. Maybe we want to receive only gets. That's something we could do. So if we switch on the request method, then on a get, then sure, let's do this thing. But if we're not on a get, if we're anything else, then we probably want to just respond with string saying that this is not implemented. Is it method not implemented? Method not allowed. There you go. Cool. So we close it and we go back in and we try to do a post. Method not allowed. Good. No chunk, no close, no size, assuming close to signal end. Okay. So maybe we still need the headers to say content length will be 0. Content type, no type. Headers. Yeah, it looks like it. It will still work for our CSS file and our make file, but it doesn't work for other methods. So let's go back to our scope and say we return the file of the contents, and then we also only respond to gets. And what else do we want to do? We've definitely done this. So done, 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 done. We can benchmark this against the Python one to see how fast we really are. Let's, you know what? Let's do unikernel stream sometime soon. It would be really cool to get my hands dirty there. Okay. So if we try to benchmark this thing, how can we do it? How can we benchmark the servers? I know of Apache Bench, I know of Seek, Apache. Let's see what's hot on the internet. HTTP benchmark. Work. What's this written in? C. Okay, I'll buy it. This one's a benchmark for 30 seconds using 12 threads and keeping 400 connections open. Cool. Yeah, let's do this. Okay. Brew, install, work. I know that some of you are not fans of Brew, but that's what I have set up right now, so I'm going to use it. So after I install work, I hope it's in Brew. Then we can benchmark both of those and take a look at the outputs. Oh crap! I should have gone to the supermarket to buy stuff to make food tomorrow morning. Damn it. Okay, so we have work and we're telling it to use 12 threads. I think I'm gonna be able to use 8 or 8 sufficiently. We can keep 400 and it's fine, and we can wait for 30 seconds. Alright, this looks about right for me. I'm just gonna copy this bits over. The endpoint is gonna be localhost 2112. And I guess we would want to serve the same file. So let's serve the main source of this source, servus.re, which is kind of funny that we're serving servus. Okay, ready? We need to see a lot of, we're gonna see a lot of logs up there. Hopefully it will not break. 1, 2, 3, go. Oh my god, so I'm receiving all of the good comments from Ann Montero telling me, dude, stop doing the fuck, what are you doing? We are supposed to be using work 2, not work, so let's see if Brew can install that. Install work 2. And I don't get why yet, so I would like to know why. Can you tell us why? And the second thing is that, okay, the work command is in there. Cool, we can take a look at that. And we want to do a profile release. We can definitely do that. I don't know if, it will be a fair do build profile release. There is no work to. I can do the release build first. It took a little longer. Now let's take a look how to install work to with Brew. Let's just copy and paste stuff from the internet because why not? Great, it's installed. So then after that we can run it and we can take a look at the command that was run by Anton Machine here. Work 2, connection 10K, timeout 5 minutes, duration 1 minute, threads 4, and then latency. Connection keep alive. I think the command that we were running is much less strenuous. Is that a word? Come on, it has to be a word. Stressing? I think stressing might be, yeah, strenuous. Yes, requiring or using great, yes, arduous. Right. I think the command we're using is more less strenuous than what it's being suggested to be done there. What do you think? Yeah, strenuous, it's a word. Yep. I'm just looking for the work one command. Wait, what am I doing? I have it on terminal. So let's close this thing. So now we should be able to, if I do make install, it should install the build, the profile, the release profile build of servos. So we have here, great. We can do servos serve, and then this starts the thing. Great. So now if we check for work, then we should be able to call work 2 with the same parameters. And this again, this is the threads, and this is the connections. And I don't remember what the D was, but it's how long it's going to take. Duration. All right, we missed something there. So connections, duration, threads. CDT. Throughput must be specified with the rate or ARM option. Okay. So let's take a look at the throughput that we were using in the comment that you sent me. Oh, it was right there. Rate 30K. So let's say rate 30K. Sounds good, everybody? and go. So after this runs for 30 seconds, we're gonna start up Python simple HTTP server, and we're gonna run this against that. And we're gonna see who wins, essentially. This is a very naive way of building the web server, and I don't think that the Python one will be faster, but it certainly has more features than the one that we have. Cool. So we have our data here. I'm going to make this wider, and I'm going to split it in two. And we're going to run the same command again on the left-hand side. But we're going to run it against Python simple HTTP server. Same port, same everything. Ready? Let's go. It's also worth noting that the Python one is doing a little bit more logging. So we could fix our logging to match this one. And we want to take a look at the request per second and how many bytes, how much data was transferred per second. And I mean, I want to be fair, like for the 2 hours we spent from 0 to getting this up and running, 4 megabytes per second is pretty good. And Python is not even close to this. It's also what? much slower. I mean, it's under a quarter slower. Connect, read 147, 1322. The average latency that we have here is 18. So in average, it's not much faster, about a second. But standard deviation is about the same. I mean, it's 5 if you want to seal it. But the concurrency, I think the concurrency is what's making this one much faster. No problem. We're ending it now. Alright, so we've managed to build a very small web server that will serve a path in your disk statically. You can use this for development purposes, or I mean, of course, it needs some more features, but you can essentially build them out very cheaply on top of the code that we currently have. And it's really, you know, HTTP AF. It is fast AF compared to other solutions that we already have, even though they are a little bit more feature rich. We have a nice command line tool for it that lets us change the folder that we're going to serve things for and the port that we're going to be using. We can even change the level of logging. Like, we can absolutely just run this thing with no logging whatsoever. And oops, sorry. It might be even faster. We've learned a little bit more about LWT and how it runs internally, and we've learned about how HTTP servers work from the very beginning. And by that I mean starting by a Unix internet address socket, and how we establish a connection by joining to that socket and listening for new connections to that socket from the clients, and then handling each one of the client connections. Yeah, look at this. I removed all of the logging, and this is just ridiculously fast. Not that you will need this speed when working, developing something, working locally, but it's nice to know that just a little bit of work, the about 2 hours that we put in the first time that we worked in this, already got us something that's pretty solid to work with. And of course, we can make sure that we understand the trade-offs of just passing in a path and not doing any validation or authorization or authentication. But those are a little bit out of the scope of this stream. I want to thank a lot to, first of all, Alan Montero for being here and helping us out figure some of these things out. I want to thank Anton Bachin for the work he does on LWT. And naturally, we want to thank as well the people responsible for httpaf, inhabited type, and I forget his full name, Spiros. Thank you, Spiros, for the work you've done. Let's make sure that we can continue to keep httpaf as a very high performance, memory efficient, and scalable web server for Camel. And if you have any questions, if you have any feedback that you want to throw at me at the libraries, just go into the repos, just leave a star if you care about them. Have a look at some other alternatives. If you want to try out the same library, you can also try it out with the async version. Async is Jane Street's version of LWT, essentially. Of course, I'm grossly simplifying here, but it will give you an idea. And if you're interested in the stream, if you liked it, go into the events sections in here. If you see the stream, and now you're gonna get this recursive stream, like inside of each other. You'll see streams into streams into streams and so on. You can go into the events sections, and in there you'll see the currently ongoing events right now, number 10. But we'll also, after a very small Christmas break or holiday break, we'll be streaming how to build a command line interface for Twitch, so that I can actually get your comments and the stats that I need on the laptop rather than having to switch into the phone and forget about, oh, I didn't see your comment, sorry there. And yeah, we have recently published a few more events all the way to January 6th, and we'll try to keep them going. If you have any idea of an event, of a topic that you want to see covered, then reach out to me. You can do it via Twitch by following me. I think you can send me a direct message as well. And also, if you want to go into Twitter, my handle is a little different than my Twitch handle is LE Ostera, which stands for my name, actually, Leandro. But feel free to follow me and just tweet at me, whatever's on your head. There's also a thread in there that exposes all of the different events that we're going to be having soon. So if you want to retweet that thread for reach, that would be great. I would be very thankful for it. And that is it for today. If you're curious about all the topics, just have a look at each one of the descriptions of the events, and maybe I can help you out with answering some questions. Soon we'll be working a lot with GraphQL, so stay tuned. Now go away from Twitch, go do some reasonable coding somewhere else, take a project that you like, and have a very nice holiday season. Thanks, and stay reasonable.